Bismillahirrahmanirrahim. Uh, Find the Y parameters of the circuit in figure 1. So this is the circuit that we are given. So the Y parameters can be found in many ways for the given circuit. So first look at the equations that describe the Y parameters. So the Y parameters are described by this equation. I1 is equal to Y11 V1 plus Y12 I2, and I2 is equal to Y21 V1 plus Y22 I2. So let me call this equation 1, this as equation 2. So these are the equations that describe the Y parameters are the admittance parameters. So one way to find out the parameters is to sorry, this is V1 and this is V2 here. V2, not this is V1 and this is V2, right? So one way to find out the Y parameters is to switch off first this voltage source and find out parameters Y1 and Y21, and then switch off this voltage source V1 and find out the remaining two parameters Y12 and Y22. So for example, if we let V2 is equal to 0, so in that case we have I1 that V is equal to 0, then I1 is equal to Y11 V1, right? And that means that Y11 is equal to I1 divided by V1. So this is admittance, right? With the units of mho or Simons. And similarly, V2 is 0. So in that case, I2 is equal to Y21 and V1. That means Y21 is equal to I2 divided by V1, right? So we can find two parameters by turning off this source V2. We can find a Y11 and Y21. So while V2 is equal to 0. So similarly, if we switch off V1, let V1 is equal to 0. So in that case, then I1 is equal to Y12 V2, and that means Y12 is equal to I1 divided by V2, while V1 is equal to 0. And similarly, I2 is equal to, in that case, is equal to Y22 V2, right? And that means Y22 is equal to I2 divided by V2, while V1 is equal to 0. So we can write them, summarize them as following. Y parameters, these are equal to this matrix Y11, Y12, Y21 and Y22. So these are admittance parameters. Note that we turned off the voltage sources first at the output port and then at the input port to find out the Y parameters. So by turning off the voltage source, we mean that we short circuit the port, right? If we want that V2 is equal to 0, so it means these two terminals are short circuited. So in that case, the resistance is 0, and the any current flowing through it multiplied with the residual resistance results in a 0 voltage. So similarly, when we turn a V1 is equal to 0, that means we short circuit these terminals, this port. So the admittance parameters are also called short circuit admittance parameters. Short circuit admittance parameters. Right? So Y11 is equal to I1 divided by V1. So this is short circuit input impedance. I1 at the input and V1 is at the input, so that is short circuit input impedance. And similarly Y21 is I2 divided by V1. I2 is here at the output port and V1 here at the input port, so that is short circuit transfer admittance from port 2 to port 1, right? And Y12 is a short circuit admittance from port 1 to port 2, right? And Y22 is short circuit admittance at the output port. So these are the four parameters, Y parameters, short circuit admittance parameters. So we can find them using this method described here. This is the standard method. Method 1, let me call this standard method. For any given circuit, you should be able to find the Y parameters using this standard method, right? So let me switch off V2 is equal to 0, and before actually we do this, we must transform the circuit to the frequency domain. The given circuit is in the time domain. The frequency component, sensitive components, for example, we have an inductor here, an inductor here, and a capacitor here. These are frequency sensitive components. So we must transform the circuit to the frequency domain first. So this 5 by 3 Henry inductor will transform to S multiplied by L. So that is L is 5 over 3, so that is 5 over 3 S, right, in the frequency domain or in the S domain using the Laplace transform. Similarly, this is 5 over 2H, 5 over 2 Henries. So that is again SL is equal to L is 5 over 2 and S from the frequency domain 5 over 2S. And this capacitor 1 over 6S, 1 over 6F farads is equal to 1 over SC. So 1 over S multiplied by 1 over 6. So that is 6 over S. Right? So the resistors are not affected by the frequency, they remain the same. So we transform this circuit to the frequency domain. Let me redraw it in the frequency domain. Let me call this fig 2. So this is 5 over 3S. This is 2 ohm, it remains the same. This is 5 ohm. This is 6 over S. This is 5 over 2S. This is 3 ohm. This is the voltage at the input port V1. This is the current at the input port I1, current at the output port I2, and the voltage at the output port V2. So now we can apply the standard method here to find out the admittance parameter. So first let us suppose V2 is equal to 0, right? The voltage at the output port is 0. So it means that the output terminals are short circuited. So let me redraw. So these terminals are short circuited, right? This is current I2 and V2 here is 0 because the impedance or the resistance of this wire is 0. So I2 multiplied by 0 here is 0, right? And this is 3 ohm. This is 5 over 2S. This is 5 over 3S. This is 2 ohm. 5 ohm. This is 6 over S. This is a voltage source connected here, right? Or a current, so we can connect a current source or we can connect a voltage source. This is I1 here, right? And the voltage here is V1, right? So let me call this fig 3. So the voltage at this point, at this is V1 at this node, and the voltage at this node is V2, which is equal to 0. V2 here is equal to 0, right? The voltage here is V2, and we can call this a reference node here, right? And this is 0 here, and this is short circuit to this, so this is V2 is equal to 0 here, and there is no current flowing through this branch because this branch is now short circuited. The current flowing from here in this direction will not follow this route. It will follow the route of the least impedance, which is zero impedance, which is this path, right? Short circuit path, and this branch is then taken out of the circuit, right? So this branch is taken out of the circuit. Let me redraw. Let me just emphasize this by drawing this dotted box here. So this branch is taken out of the circuit because of this short circuit here. So we can write I1 is equal to, this I1 is equal to V1 divided by this, right? V1 divided by 5 over 3s plus 2, right? And then this current here, this will be V1 minus 0. So this is V1 minus 0 divided, because this is 0 here, right? So this will be 6 over s plus 5. 6 over s plus 5, right? So so this is I1 is equal to, so LCM is 3, so 3 here will at the denominator will go here, so that is 3V1 divided by 5s plus 6, right? And then we have s here, so s in the denominator will go here, so that will be SV1 divided by 5s plus 6, 5s plus 6. The denominators, both the terms are the same, so we can write it like this: I1 is equal to s plus 3 divided by 5s plus 6 V1. So that means I1 divided by V1 is equal to s plus 3 divided by 5s plus 6, but that is equal to Y11, right? So we have found one parameter from this figure, right? So similarly we can write an equation for I2 also. So the current I2 flowing from here in this direction, I2 is given by 0 minus V1, right? So this is 0 minus V1 divided by, this will be 6 over s plus 5. 6 over s plus 5. So that is minus SV1 divided by 5s plus 6. 5s plus 6. But that is I2 over V1. I2 over V1, and I2 over V1 gives us this parameter, right? Y21. So that is Y21 is equal to minus s over 5s plus 6. So we have found out two parameters by letting V2 is equal to 0 and short circuiting the output port. So now to find the remaining two parameters, we let V1 is equal to 0 and we short circuit the input port. Yes, we can assume a current I1 flowing here, right? and the voltage here is definitely V1, right? The voltage across these terminals, let me say this is I1, and let me keep this as V1, the voltage across these terminals. So let us now find the remaining two parameters by short circuiting the input terminal, right? So let me redraw the figure. Let now V1 is equal to 0. So V1 is equal to 0. So that means we are short circuiting the input terminals. This is the resistance, then this capacitor here from this circuit, and we have this branch here. So we are short circuiting this input terminals, right? So V1 is 0 here. V1 is 0, and the current flowing in is I1, and we are short circuited this, right? And this is 0, so V1 is equal to 0, and this means that V1 is 0 here as well. So that is 2 ohms, that is 5 over 3s, this is 6 over s, this is 5 over 2s, this is 3 ohm, and the voltage at this output port is V2, and the current flowing in here is I1, and we can connect current source, sorry, this is I2, current source I2 here, right? I2, and the voltage across these terminals is V2, and let me call this fig 4. So now again applying KCL at this node, and note that now this branch is short circuited, so this branch is out of the circuit, so there is no current flowing in across this branch, because all the current will follow the path of least impedance, least resistance. So the current basically flowing through this short circuit will go flowing here will follow the path of the least impedance and go through this short circuit. So I1 is equal to this is 0 minus and the voltage here is V2, this is node V2, right? So 0 minus V2, and that is 6 over s, and this is 5 ohm, right? This is 5 ohm, 6 over s plus 5, and that is minus s V2 divided by 5s plus 6. So that means I1 divided by V2. So I1 divided by V2 is equal to Y12. So that is Y12 is equal to minus S over 5S plus 6. So this gives us the third parameter, right? And we can similarly apply KCL at this node as well. So I2 from here is equal to the current through this branch plus current through this branch, V2 divided by 5 over 2s plus 3 plus V2 minus 0 divided by 6 over s plus 5, right? So I2 is equal to, so we take the LCM as 2, so this becomes 2V2 divided by 5s plus 6, and we take LCM, S as LCM, so this is S V2 divided by 5S plus 6, right? So in other words, I2 is equal to, and the denominators for both the terms are the same, so we can add them together. So that is S plus 2 V2 divided by 5S plus 6. So I2 divided by V2, this gives us the fourth parameter. So I2 divided by V2, that is Y22, and that is equal to S plus 2 divided by 5S plus 6. So we have determined all the four parameters using this standard method, and we can write them in the matrix form, in the summarized form. So y11 was S plus 3 over 5S plus 6, S plus 3 over 5S plus 6. Then we had y12, and that is equal to minus S over 5S plus 6. Y21 is also the same. This circuit is reciprocal, minus S over 5S plus 6. And Y22 was found out to be S plus 2 over 5S plus 6, right? So we have determined all the four parameters using the standard method. And note that the circuit is reciprocal. As y11 is equal to as y12 is equal to y21. Whenever the circuit is linear and has no dependent sources, the circuit is reciprocal. And in that case, we can imply the method 2 also. Method 2. So rather let's use yes, okay, let's apply method 2 with when the circuit is reciprocal, when the circuit is linear, when the circuit is linear and has no dependent sources, it is reciprocal and can be expressed in an equivalent pi network, right? So equivalent pi network is given like this. Our given network is also a pi network, right? Though this is in the form of a pi. So we can compare the given pi network with the standard pi network, and then we can find out the y parameters. So this is the standard pi network for when the circuit is linear. So in that case, when the circuit is linear and has no dependent sources, so it can be expressed in this standard form. Let me call this fig 5. So in that case, this is minus y12 is equal to minus y21. Whatever the admittance is here, the negative of it will be equal to y12 or y21. Or in other words, minus y12 minus y21 will be equal to the admittance here. And this admittance here is y11 plus y12, and this admittance here will be equal to y22 plus y21 or y12. This is, and this is I1 here, this is V1, and the voltage here is V2, and the current flowing in here is I2, right? So comparing the given circuit with that in figure 5, comparing the our given circuit is linear and has no dependent sources, so we can find out the parameters using this method. So comparing the given circuit with that in figure 5, we can see that y minus y12 is equal to minus y21 is equal to the the admittance 1 over impedance, right? 1 over impedance, 1 over impedance is 6 over s, right? 6 over s plus 5, 6 over s plus 5, right? So that is equal to, so that is s over 5s plus 6. So minus y12 or minus 21 is equal to this one, and y12 or y21 is equal to minus 5s over 5. We multiply both sides with the minus 1, right? So that means y12 is equal to y21 is equal to minus s over 5s plus 6. So this is the same that we have found here, right? y12 and y21, these are the same, right? And then y11 plus y12 is equal to the admittance of this branch. So admittance is 1 over impedance, so that is equal to 1 over 2 plus 5 over 3s, right? 1 over yes, so that is 1 over 5 over 3s plus 2. So that is equal to, we take the 3 as LCM, so this is 3 divided by, so this is 5s plus 6. So this is y11 plus y12. So we already know the parameter y12, so we can substitute the value here. So y11 is equal to 3 over 5s plus 6, and this is minus s over 5s plus 6, and this is minus y12 here. So minus minus this becomes plus 3 over 5s plus 6 plus s over 5s plus 6. So y11 is equal to s plus 3, right? So s plus 3 divided by 5s plus 6. So this again is the same parameter that we have found here for y11. And now y22 plus y21 is equal to the admittance of this branch. So that is 5 over 1 over 5 over 2s plus 3, 1 over 5 over 2s plus 3, right? So that is equal to 2 divided by 5s plus 6. So y22 is equal to 2 over 5s plus 6 minus y21, 2 over 5s plus 6 minus y21. So minus y21 is equal to s over 5s plus 6, right? So the denominator is the same, so y22 is equal to s plus 2 divided by 5s plus 6, right? So we have determined all the 4 parameters using the second method. But to apply the second method, you must ensure that the circuit is linear and has no dependent sources, and that it is reciprocal. So then, only then you can apply this method, right? So we can still use another method. There are other ways to find the y parameters from this circuit. Let's call that method 3. So for that, let me redraw the circuit again in its frequency domain form. So this is 5 over 3s, this is 2 ohm, this is 5 ohm, this is 6 over s, this is 3 ohm, this is 5 over 2s. The voltage at these terminals is V2, the current flowing in here is I2, the current flowing in here is I1, and this is V1. And let me call this figure number 6, right? So we can, for example, use simple circuit analysis techniques to arrive at equations which are similar to the equations here, and then we can compare the coefficients of both these equations to find the short circuit admittance parameters, the Y parameters. So for example, if we apply KCL, this is the pi network, so if we apply KCL at this node, the voltage here is V1, right? And at this node, this is V2, this is V1, and this is V2, and suppose this is the reference node. So if we apply KCL at node V1, so then I1 is equal to the current through this branch plus the current through this branch. So we can write V1 divided by, for example, 5 over 3s plus 2 plus V1 minus V2 divided by 6 over s plus 5. So I1 is equal to, so this is 3 in the, we take this as LCM, so this will become 3V1 divided by 5s plus 6, and then we take s as LCM here, so that is s into V1 minus V2 divided by 5s plus 6. So we combined the terms for the V1 together and V2 together, so that we can write I1 is equal to, so this is SV1, this is 3V1, so this is S plus 3 over 5S plus 6 V1, and then we can write minus S over 5S plus 6 V2. So these were our equations 1, 2, right? And let me write it as equation number 3, right? We didn't use any other equation number. We did not number any other equations. So let me write this equation number 3. So similarly, KCL at V2. KCL at V2 gives I2 is equal to the current through this branch plus current through this branch. So this is V2 divided by 5 over 2s plus 3, right? And plus V2 minus V1 divided by 6 over s plus 5. So this becomes I2 is equal to, so this is 2V2 and this is 5s plus 6, and plus the s here is the LCM, so s into V2 minus V1 divided by again 5s plus 6. So we combine the terms for V1 and V1 together and then V2 together, and we can rewrite this. I2 is equal to, so this is for V1 we are minus V1, so s, so this is minus s over 5s plus 6 V1, and then for V2 we have SV2 plus 2V2, so this is plus s plus 2 divided by 5s plus 6 v2, right? So let me call this equation 4. So comparing now 1 and 2 with 3 and 4 respectively. So if we compare these equations, this here I1 is equal to this term V1 minus this coefficient with V2 with this equation. So this coefficient here is Y11 and this coefficient here is Y12. Similarly, if I compare this equation I2 with this equation here, so then this coefficient here is Y21 and this coefficient here is Y22. So we can write down the impedance parameters again. So this is S plus 3 divided by 5s plus 6, and then minus s over 5s plus 6, again minus s over 5s plus 6, and s plus 2 over 5s plus 6. So we have found out the impedance parameters by yet another method, and there is another method also. There are actually we can apply other techniques to rewrite equations in this form, and then find out the y parameters. Or we can, if we know other parameters, for example, if we know the z parameters, we can apply methods to transform the given the z parameters to find the equivalent y parameters. For example, if we know the z parameters, then the equation for the z parameters, if we know, or if we have found out, or if we can determine z parameters, then equation for the z parameters is in this form. So v1 is equal to z11 I1 plus z12 I2, right? And v2 is equal to z21 I1 plus z22 I2. So these can be written actually like this: z11 z12 z21 z22, and then this I1 and I2 is equal to this V1 and V2. So we can rewrite these equations in this form, right? And then find out the y parameters by comparing with them with this equation. We can rewrite these equations in this form here to find out the parameters. For example, let me call this equation 5 and let me call this equation number 6. So we can use Cramer's rule to find out the values of I1 and I2, and then we can rewrite these equations in this form here to find out the y parameters. So for example, the denominator delta, this denominator for this matrix delta, or let me call this dz, is given by this z11 z12 z21 and z22, right? And delta or dz is equal to z11 z22 minus z12 multiplied by z21. And similarly, delta 1 is given by v1 and v2 here in this column, right? And we leave this column as is, z12 and z22. So that is equal to v1 z22 minus z12 and v2, right? And similarly delta 2 is equal to, this is we leave this here, z11 z21, and this is v1 and then this is v2, and that is then equal to z11 v2 minus z21 v1. So then I1 is equal to del 1 over del, right? So this is z22 v1 minus z12 v2 over delta, which is dz. So I1 is equal to z22 over dz v1, and this is minus z12 over dz v2. Now this equation is in the same form as this equation, right? So let me call this equation number 7, and I2 is equal to del 2 over del, and I2 is equal to del 2 is here. So this is minus z21 v1. So this is minus z21 v1 plus z11 v2 divided by dz. So I2 is equal to minus z21 over dz v1 plus z11 over dz v2. This is equation number 8. So comparing equation 7 and 8 with equation 1 and 2, we can write down the y parameters is equal to y11, y12, y21, y22 is equal to, so this is z22 over dz, right? And then this is minus z12 over dz, right? And here we have minus z21 over dz, and we have z11 divided by dz. So if we can determine the first the z parameters, then we can imply this method to find the y parameters from the z parameters. Or if we already given the z parameters, or if we know the z parameters somehow, we can determine the equivalent y parameters using this equation. In fact, if any other form of any other parameters are given, they can always be transformed to the y parameters using similar method. For example, if we are given hybrid parameters, these can also be transformed to the y parameters. We can find out the y parameters from the set of the hybrid parameters that we are given. So if any one form can be from the one form, from the one set of parameters, we can always derive the other set of parameters. So this is yet another method to find out the y parameter. I did not find the z parameters for the given circuit because it might be somewhat complex. The methods described earlier are quite easier to find the z parameters. However, if some circuit is if there is a circuit for which we can find the z parameters easily, then we can first find the z parameters for that circuit and then apply this method to find out the y parameters if the determination of y parameters is difficult directly.